Hello good people, I'm going to talk about the Cartesian plane. The Cartesian plane, or the coordinate plane, helps describe the position of any point on a plane using ordered pairs or coordinates. It was named after the French mathematician and philosopher René Descartes, who developed this technique of plotting points. You may have heard the name Descartes, as he is also known for his philosophical statement, "I think, therefore I am." Although, to be honest, I think it should be "I think, therefore I do not know." Alright, so what does a Cartesian plane look like? To begin with, we have two axes. There is the horizontal line, the x-axis, or the independent axis, and we also have the vertical line, which is the y-axis, or the dependent axis. The point where these two axes meet is known as the origin. In order to plot anything on this Cartesian plane, I need some intervals. Note that the intervals should be equally spaced on the individual axes, but they do not have to be the same on both axes. What do I mean by that? Well, if I examine the x-axis, each interval represents a value or a change in 2. So we go from 0 to 2 to 4 to 6. On the y-axis, I have decided that each of my intervals represents a change of 4. So we go from 0 to 4 to 8 to 12. The Cartesian plane is divided into 4 quadrants. We start in the upper right and then work our way counterclockwise. Most of the graphing is usually done in quadrant 1, where all the values are positive. Now that we have the Cartesian plane, let's plot a few points. Please note that when we give coordinates or ordered pairs, they are given using the x-y format. This means that the first value represents the x value and the second value represents the y value. Point A has a coordinate of 6, 8. This means that it is 6 on the x-axis and 8 on the y-axis. Point B has a coordinate of -4, 6, meaning we are -4 on the x-axis and 6 on the y-axis. Point C would be -2 on the x-axis and -8 on the y-axis. And finally, point D with the coordinate of 6, -10 is 6 on the x-axis and -10 on the y-axis. Now that we have some points, we can also create a few lines. To begin with, I'm going to create line AC. This line AC has also created 2 points of interest. The first one is the x-intercept. X-intercept is the point where our line meets the x-axis. In this particular case, the coordinate for the x-intercept is 2, 0. The general expression for any x-intercept is that at x-intercept y is 0. And so the general coordinate might be written as x and then comma followed by a 0. The x will be wherever our line crosses the x-axis. The second point of interest is the y-intercept. This is the point where the line hits the y-axis. In this particular case, the coordinate for the y-intercept is 0, -4. The general expression for any y-intercept is to say that at the y-intercept, x equals 0. And the general coordinate would be 0 and then comma followed by y. The letter y represents the value where the line hits the y-axis. Let me draw another line, this time line BD. Line BD comes with its own x-intercept and y-intercept. However, I am not interested in those right now. What I am interested is in this point here, where our two lines meet or cross. This is known as a point of intersection. It is a point of commonality, a point that exists on both lines. At that point, two mathematical statements hold true. The first one is that whatever the x of one line has to equal the x of the other line. In this case, the black x equals the orange x. The second statement is that the corresponding y values are also equal. In this particular case, black y has to equal orange y. We are going to explore this more when we look at how to actually calculate the point of intersection. Something to look forward to. Aside from mathematics and sciences, the Cartesian plane is also used in orienteering and cartography. In fact, the compass rose can be seen as a version of the Cartesian plane. The x-axis is represented by the west and east points, while the y-axis is represented by the south and north points. There is an apocryphal story that states that Descartes came up with the coordinate system while navigating the narrow streets of Amsterdam and trying to figure out the best route between his two favorite pubs, a house of negotiable affections, and his apothecary, who provided Descartes with ointments to deal with various rashes. That is all for now, and I will see you on the flip side.